everyone, welcome to CSE Core Concepts in my series of searching and sorting. In this video, we are going to discuss about another sorting algorithm called as quicksort. Quicksort is also called as a divide and conquer technique because here we are going to divide, or we are also called this as a partition exchange sorting. That means we are going to partition the array of list, array of elements, and then we are going to perform sorting by exchanging the elements. Now here we require something called as a pivot element, right? So now initially we will select any element, any one of the element as a pivot element, and we assume we are going to rearrange in such a way that the elements on the left side of the pivot are smaller or equal, and greater elements should always be on the right side of the pivot. And same procedure we are going to recursively apply for each sublist from left to right and right to pivot. Okay, so let's understand it using this array having 6 elements. So initial stage, we do not know what is our pivot and where to start from. So let me select the leftmost element or the first element as my pivot, since I don't know anything about the array right now. Fine. And the leftmost element is what? 0th element. Pivot and leftmost element both are same initially. Fine. And the rightmost element is the 5th element. Fine. So A of left is, what is the value? 24. A of right is 27. Fine. And A of pivot is also 24. Now pivot is on the left hand side, so the algorithm will move from right to left. Okay, so please understand this, right? This is very crucial. If the pivot is on the left side, okay, the algorithm will move from right to left, and if the pivot is on the right hand side, the algorithm will move from left to right. Okay, so with this technique we are going to start comparing from right to left. Now the first elements, that is the left and the right, will be compared. Sorry, the pivot will be compared. So what was your A of pivot earlier? 24. Fine. A of pivot is 24. A of right is 27. Right. So here you can understand that 24 is less than 27. Okay, so I don't need to swap it, because what did we say? That on the left hand side of the pivot, the elements should be either less than or equal to them, and on the right hand side, the greater element should be there. So 27 is greater than the pivot element, so it is already on the right hand side. We don't need to swap it. Okay. So now next step is that we will move one position towards the left, because I told you since pivot is on the left hand side, we will move from right to left. So right will be moved one step towards left, that is, now my A of right is 19. Okay, pivot is same, pivot is 24, A of right is 19. So now you compare the pivot element to the right element. So 19 is smaller than pivot. So actually what does the rule says? Smaller element should be on the left hand side of the pivot. So I have to swap it. Okay, so whom should I swap? Pivot and the right element. So 19 will come at the 0th position and 24 will go on the right position. And since one swapping has been done, now my pivot will move to the right hand side. So my pivot is now who? 24 is my pivot. Understood? Now since pivot is on the right hand side, my algorithm will now move from left to right. I hope it is clear. So now since it is, the algorithm will move from left to right. Great. So now one step left will move towards the right. So my left is now 9 and pivot and right both are at 24. So let us compare 9 and 24. 9 is smaller than 24. Okay. So pivot is, so smaller elements are on the left hand side of the pivot. Well, nothing needs to be done. Next step, you have to move one step towards the right. No swapping has been done. So move one step towards right. Left will move one step towards right. So my left is now the second position, that is 29. Now compare the value of left and pivot. Pivot is same, right? So now compare 29 and 24. Now 29 and 24, you can see that 24 is smaller than 29. So there will be a swapping. So 24 will go to the left position and 29 will come to the pivot right position, right? Now since there is a swapping, pivot has gone to the left position. Now when pivot has gone to the left position, algorithm will move from right to left, right? So now algorithm has moved one step towards the left. Right is now your 14, right? And pivot is your 24. Okay. So now again you compare pivot and right element. 14 is less than your pivot element 24, yes, so you have to do a swapping. So 14 will come at the second position and 24 will go at the third position. Now since the swapping has been done, pivot will also become your right. So now your right and pivot both are 24. I hope it is clear, right? Now pivot is at the right, so now you will move the algorithm from left to right. Now the situation is that you have got the two subtrees. Understood? So now when your pivot is at the right, algorithm will start from left and moves towards right. So your left will now be at third position. So your third position is your pivot also. Third position is left also. Third position is right also. Right. So now what will you do here? You are going to do what? You are going to have two subtrees now. A left subtree and a right subtree. Understood? So you have partitioned them. Now for each subtree, because your left, right and pivot both are 3. Fine. So now what you have to do, that element 24 which is the pivot element, so whenever your left, right and pivot both are, all three are same, that means the termination of the procedure. So element 24, which is the pivot element, is placed at the exact position. See, 24 is at the correct position, right? Elements that are on the right hand side of the 24 are greater than 24. I agreed. 29 and 27 are greater than 24. And elements which are smaller than the pivot are on the left hand side. 19, 9 and 14 are on the left hand side. So now what you will do is, you are going to apply quick sort separately on the left subtree and on the right subtree. I hope it's clear. So now let us consider the left subtree. Okay, the whole process will be repeated. Right, so where did we start from? Initial state is that the 0th element is our left, the rightmost value is the right, and pivot will be starting to 0. Right, so now you compare pivot and right. 19 and 14. 14 is smaller than pivot, so there will be a swapping. 14 will come to the 0th position, 19 will go to the second position. So pivot will also change. So when the pivot has moved towards the right hand side, the algorithm will proceed from left to right. So left is now your first position. So now you compare the left value and the pivot value. 9 is less than 19, yes. So what you are going to do? You are going to, now you don't have to swap, because pivot say 9 is smaller, so it is on the left, right? But left will now move one position. Now when left moves one position, what will happen here? Left, right and pivot, all three are your second position. And I told you that when all the three values are at the same position, this means there is a termination of the procedure. So now you are left with two trees. Left subtree is 14 and 9 and the right subtree is 19. Understood? So now for 14 and 9, again you have to do a quick sort. That is, you have only two elements. Left pivot is 14, right is 9. Compare 14 and 9. You have to do a swapping. After you do a swapping, you will move one position to the right. Okay, so left, right and pivot, all three are first. Termination is done. Right. So this way we have been able to solve the left subtree. Now same process we are going to do for the right subtree. So if you want to do for the right subtree, what will you do? 24 will become your left pivot and 27 will become your right. You compare 24 and 27, no swapping, fine. Move one position to the right. Okay, so next is your 29 and 27. Yes, they need a swapping. So 29 and 27 will be swapped to, and the left will go to fifth position. That is 27. Left, right and pivot, all three are at 27. Tree is sorted. Array is sorted. Okay, so this will go on applying till you get, when you do the termination, when your left, right and pivot are at the same position. So here the time complexity is what? You divide the trees. So obviously logarithmic time will be there. But you are going, in the first iteration, we are going to check for all. Remember. So one iteration for all, that is n, and then left tree, right tree, left tree, right tree. So logarithmic time. So the total time complexity is O into O of n into log n. I hope you understood. Quick sort, you can practice more, and if you have any doubts, please write in the comments section. I will be happy to solve your doubts. Don't forget to like, share and subscribe to CSE Core Concepts. Thank you.